Hello, geometry students. Today I'm going to talk to you about the altitudes of triangles. So what is an altitude? The altitude of a triangle is a line segment through the vertex of a triangle that is perpendicular to the opposite side. In other words, it makes a right angle with the opposite side or with the line containing the opposite side. So the altitude of a triangle is a segment through the vertex of a triangle perpendicular with the line that contains this opposite side. Vertex, opposite side. Now, with altitudes, they could be inside, on, or outside the triangle, and I'll be modeling that. And notice every triangle has three altitudes, because they have three vertices and the vertex is the starting point. So I can go from triangle ABC, I can go from vertex A, make a right angle with the opposite side. I could start at vertex B and make a right angle with the opposite side. Or I could start at vertex C and make a right angle with the opposite side. So every triangle has three possible altitudes. The altitudes intersect, or their point of concurrency, is here at point O, and it's called the orthocenter. Pause and on your own paper, draw three altitudes inside an acute triangle. So draw an acute triangle on your paper and then draw the three altitudes, one from each vertex. Just try to sketch it. So the first one you can draw from the vertex, make a right angle with the opposite side. The next one, go from the second vertex, make a right angle with the opposite side. And then the third one, you can start at the vertex and make a right angle with the opposite side. And notice those three altitudes intersect in the orthocenter. So altitudes inside an acute triangle, the orthocenter will always be inside of the acute triangle. So the acute triangle is in black and the altitudes are in red. So now pause and on your own paper, draw the three altitudes of a right triangle and then press play. So if I go from the vertex at the right angle, it's easy to make a perpendicular with the opposite side. In order to go from this vertex and make a right angle with the opposite side, I have to actually be the side. And likewise from this vertex, this side is an altitude. So for the right triangle, the two legs of the right triangle are altitudes of that triangle. And the third altitude is here. And so notice the three altitudes intersect at the orthocenter. And notice in this case, the orthocenter is on the right triangle. Now this is the trickiest one, because remember the definition says that an altitude of a triangle is a segment from a vertex forming a right angle with the line containing the opposite side. So when it comes to the obtuse triangle, we're going to have to make extensions of the opposite side in order to achieve this goal. Give it a try on your own paper and then press play for the solution. The easiest altitude to see is from the vertex at the obtuse angle, and you can easily make the altitude right angle with the opposite side. It's a little trickier when I go from this vertex, because in order to make a right angle with the opposite side, I have to extend the opposite side. So this dotted line is just an extension of the opposite side, and then I can drop down my altitude. Likewise, from this vertex, here's the vertex, here's the opposite side. I have to extend the opposite side in order to achieve a perpendicular with the extension of the opposite side. Now notice, I have to also extend all three of the altitudes in order to even get them to intersect. And only in that moment will I find the orthocenter, way out here. Now, just to remind you, the black triangle is the triangle in question. Pink, blue, and green are the altitudes, and yellow is the orthocenter, all pertaining to this black obtuse triangle. So for the obtuse triangle, notice that the orthocenter is outside of the triangle. So pause and answer these questions and then press play. Remember, an altitude goes from a vertex and makes a right angle with the extension of the opposite side, or PR. And a median is a segment that goes from the vertex of the triangle to the midpoint of the opposite side, or QT. So pause the video and answer these 3 questions, and then press play for the solution. A median goes from the vertex to the midpoint of the opposite side, so AD. An altitude goes from the vertex and makes a right angle with the opposite side. And in this case, EG is neither. So you can see that our median is AD, our altitude of ABC is CF, and EG is neither, because it goes from midpoint to just some random point on the side. It doesn't say anything specific about G. So as an overview, medians go from the vertex to the midpoint of the opposite side, and they intersect in the centroid. And altitudes go from a vertex, make a right angle with the opposite side, and they intersect in the orthocenter. So I will leave you with this cute picture of the baby leopard and wish you a great day.